Okay, this is section 2.4. This is again more solving equations. This is a big part of algebra in general. And I know this is something that you've probably seen prior years, but we really focus on it a lot in Algebra 1 at the beginning because we use it all year. So now we're going to get into solving equations when we have variables on both sides. So again, just another layer to the difficulty of it. So what we want you to do is be able to do is solve an equation with the variables on both sides. Okay. Again, you use properties of equality, the inverse operations, all of that stuff. But our goal is still the same. We want to get x all alone with a 1 in front of it on one side of the equal sign. Okay? So, first thing we're going to do, we have 5x plus 2 equals 2x plus 14. So let's just act like we were looking at this side, and you wanted to get your 5x all alone. Okay? What would you do to it? First thing you would do is subtract 2. So now you still subtract 2 from the other side. Why don't you subtract 2 from the 2x? Because this 2 does not have an x. They do not have the same variables. So these cancel. We are left with 5x on this side equals 2x plus 12. Now, what do we do on this side? Well, we want to get all the x's on one side, and we already have the 5x all alone over here. So we're going to subtract 2x from both sides. When we do that, these cancel. 5x minus 2x is 3x equals 12. And now, divide by 3, both sides. Those cancel, and you are left with x equals 4. All right, let's try another one. So the thing I always get to is can we move the k's over to the right-hand side? And the answer is yes. But there's usually a reason or something that makes it easier. Basically, if you don't want to have to deal with negative numbers in front of your k, what I would suggest is whichever one is bigger, the 7 or the 4, the ones that are attached to k. Whichever one's bigger, leave that on that side, because now when you subtract 4, you'll get 3k over here. If you subtract 7 from both sides, you'll get negative 3k over here. So I would suggest moving the smaller one. Just think of it as that. It's easier to move a smaller thing. So we're going to subtract 2 from both sides. We get 7k equals 4k minus 12. Now here we subtract 4k. Subtract 4k here. Remember, we're not dividing. 7k minus 4k is 3k equals negative 12. We divide both sides by 3. Those cancel. Looks similar to the last problem, except negative 12 divided by 3 is negative 4. Okay, we're going to hop over the word problem for right now. We'll come back to it. Sometimes you have to distribute prior to solving. Okay, nothing changes compared to what it was before. So you distribute first. 2 times 5x is 10x. 2 times negative 1 is negative 2. Equals 3 times x is 3x. 3 times 11 is positive 33. And again, I'm going to leave the 10x over here and move the 3x. Now, can you do them in opposite order? Sure, you can subtract 3x first. Now you have these cancel, and you're left with 7x minus 2 equals 33. And then you add 2. Those cancel, which means you have 7x equals 35. And then finally divide by 7, and x equals 5. We're going to try one more. I'm going to do A together, and then I'm going to let you do B by yourself. Okay? So A would be 4 times 2, y, and 4 times 1. So 4 times 2y is 8y, plus 4 times 1 is 4, equals 2 times y is 2y, 2 times negative 13 is negative 26. I am going to leave the 8y over here and move the 2y over, but first I'm going to subtract 4. When I do that, I get 8y equals 2y minus 30. And then if I subtract 2y, these cancel, and we are left with 6y equals negative 30. Don't forget about that negative. Divide by 6, and we get y equals negative 5. Go ahead and pause the video and try to do B on your own. Okay, now that you've paused it, I'm going to do this one just to show you. 7 times 4 is 28. 7 times negative a is negative 7a, equals 3 times a, and 3 times negative 4. 3 times a is 3a. 3 times negative 4 is negative 12. So now, remember how I said you always, it's a good idea to leave the smaller, or I'm sorry, the bigger number on its side. You say, well, 7's bigger than 3, right? Well, if you subtract 3, negative 7 minus 3 is negative 10, and now you're having to deal with a negative number. It's okay, you can do that. But if you don't want to do that, think about it. What's bigger, 3 or negative 7? 3 is bigger. So instead, I'm going to move 7a over. I have to add 7a so that they cancel. And then when I add 7a over here, we end up with 10a minus 12. Add 12. Those cancel, and you get 10a equals 40. Divide by 10, and you are left with a equals 4. So this is the video. Again, take your time with it. The only difference is having to move variables from one side to the other. Other than that, it's very similar to your previous equations. If you have any questions, write them down. Bring them into class.